We continue now to finalize the script that will do this phylogenetic analysis. And for this reason we will use the RAXMLNG software, which is a software that builds phylogenetic trees, reconstructs phylogenetic trees using the maximum likelihood method. So if we type RAXMLNG, RAXML-NG in Google, then we will see that the first result is the source code of the file in the GitHub repository. So what I need to mention here is that some of the programs that we will use in bioinformatics or in computational biology exist in the repository of the Linux distribution, for example in Debian or in Ubuntu, etc. Other programs do not exist in this repository, and we have to either find the source code and compile them if they are C program or C++, or just download them and use them if they are Perl or Python or R. So Perl, Python, R and other languages are interpreted languages, which means that they don't need to be compiled. We don't need to compile the source code and create an executable file. We can run the source code directly because it's interpreted. But some other tools, some other software like RAXML, which is written in C or C++, we need to compile them and convert the source code from human readable format, which is a source code, to something that the machine understands. Okay, so I will just show the whole process here, how to do that, even though there are other variations of this process depending on how the developer has built up the whole process. Okay, so I go to this site, which is a GitHub repository for RAXMLNG. This does not mean that you will find all software in GitHub. Many softwares that we use in bioinformatics are in GitHub, so this will be the process to get them. But other software is in the web page of the developer, for example, or in the web page of the group, or in the web page of the university. But here we will just use GitHub. So I go to this to the home page of RAXMLNG in GitHub, and if the developer is quite careful, and actually the developers of this software are quite careful, they have written an extensive manual here. So there is this introduction. RAXMLNG is a phylogenetic tree inference tool, okay, using maximum likelihood. Then there are these installation extractions, so it's very simple to download the precompiled binary file and run it immediately. I will not do that. I will just follow the process down here because it's more usual for other software as well. So in RAXML you can find the compiled version, but in other software you will not be able to do that, so I just want to demonstrate how to do it here. Okay, so the first step is to install the dependencies. RAXMLNG is a software that depends on other libraries, and I need to do that. And you see here that I can install these 3 programs, Flex, Bison and Leap GMP3-dev using the sudo apt install. Okay, to do that I need to be a user that has sudo permissions. I cannot do that as student in this server, but I can do that with my name. So if I will paste it here, I can do the installation, but I have already done it before, so it says here that all these 3 programs are in the newest version. It will not do anything. But if they would not be installed already, then this command would install them. Okay, then I continue to the next step. The first step is to download the source code. So this git command is connected to the repository in GitHub and downloads the source code for XML-ng. Quite often you will see this command without the -- recursive, but here, because you download the whole file system, subfolders within folders and so on, this -- recursive is needed. So the first thing is to download everything. Okay, I go here. Now I don't want to put everything in this file. I will just make another folder called software. Okay, and I will go inside the software and put everything inside there. So I run this command, and this recursively will download everything that is inside the XML-ng. Okay, so everything has been downloaded now. If I will ls, I see here there is a folder called XML-ng. Usually this folder is the same name like the last thing in the GitHub the GitHub directory. Okay, so if I will go inside the XML-ng, I can see what I have downloaded. Of course, I don't know what to do with them, but luckily the developers describe here what to do. So this is what I have done already. Then it tells me, okay, go inside the XML-ng directory. I have done it already. Then it tells me create a directory called build and go inside there. Okay, copy it, I paste it. So you see now that I went inside the build directory. Now, just to say here that here there are two commands, one after the other. One is the make dir build, and then go inside the build. This ampersand end means that execute the second command only if the first one is executed successfully. So if you manage to execute this command, then execute this command. And quite often in pipelines, it's better to use the ampersand instead of splitting these two commands in separate lines, just because the second command directly depends on the successful execution of the first one. Okay, so I'm inside build now, and then the next step is to use the cmake command to create all files needs for the compilation. Okay, cmake / cmake ... So I need this ... because the cmake command needs to run not in this build directory, which is empty, but it needs to run in one directory higher in the hierarchy, so in the parental directory. This means the ... I can put it here like that also to be more clear. Okay, it will compile it will create all the files needs for the compilation, and then it tells me, okay, now run the make command to compile the C code. If I will ls now, I see that all these files have been generated from the cmake command, and especially the make file contains all the instructions how to build the executable file out of the source code. Okay, so make, it will take some time because it's quite a large program. So I see now that I'm in the 5%, 6%, there are some warnings, doesn't really matter so much. 10, 11. and we can wait for a while until the source code will be compiled.